Section 5.6 is angle bisectors and perpendicular bisectors. So the distance from a point, so here you can see point C, to a line, line AB, is measured by the length of the perpendicular segment from the point to the line. So perpendicular segment would mean 90 degrees. So that would be measured from point C to point D by the perpendicular segment. So why does that matter? When a point is the same distance from one line as it is from another line, so you can see that marked here, we have point A that is the same distance from line M to line N, and you know that because they are marked congruent. So when that's the case, the point is said to be equidistant because it is an equal distance from the two lines. So we can say point A is equidistant from lines M and line N. So why did this 90-degree angle matter here? So you can see we have that our perpendicular segment from the point to the line here and here. Now if these aren't 90 degrees, then these two lengths are not equidistant and they will not be congruent. So the angle bisector theorem says if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So what that means here is that if a point B is on this bisector AB, so if AB, ray AB, bisects angle CAD, so here's our bisector, then we know that the distance from C to B and B to D is the same. It's congruent. So we know that CB and DB are the same. So let's draw that in. And BD are congruent. And then these are going to make a 90-degree angle. So again, if the point is on the bisector, so B is on the bisector of ray AB, then it is equidistant from the two sides of the angle. So this is the same distance as this. So for example, find the length of FH. So we want to find this length. Now, since these are both 90-degree angles, we know that point H is an equidistant from the two sides of the angle. So we know that x plus 3 equals 2x plus 1. Now we can solve this equation. I'm going to move my variable terms to the right side. So we get 3 equals x plus 1. And since I put my variable terms on the right side, I'm going to move my constants to the left. So we get 2 equals x. But that is not what we were looking for. They wanted us to find the length of FH. So now that we know x is 2, we're going to plug 2 in for x. And 2 plus 3 means that the length of FH is 5. So again, M is a point on this bisector. And since we have these 90-degree angles, we know that the distance from M to this side is the same as the distance from M to this side. So we know that these segments are congruent. And if they're congruent, that means that they are equal. So we can set 4x equal to x plus 15. I'm going to move all my variable terms to the left side. So we get 3x equals, that's supposed to be 15. 3x equals 15. Divide both sides by 3. And we get x equals 5. But that's not what I was trying to find. They want me to find the length of MK. So MK is x plus 15. So I'm going to plug in 5 for x, and 5 plus 15 means that MK is 20. And since MK is 20, we also know that ML is 20 because they are congruent. So one more. We know that these are congruent. We can set them equal. X plus 1 equals 2x minus 1. Subtract x from both sides. We get 1 equals x minus 1. Add 1 to both sides, so my constants are going on the left side. We get 2 equals x, but we want to find the length of EF. So EF is x plus 1. So let's plug in a 2 for x, and we get that the length of EF is 3. All right, second part to this lesson. A segment, ray, or line that is perpendicular to a segment at its midpoint is called a perpendicular bisector. So you can see perpendicular, and we call it a bisector because the midpoint is the halfway point, so we know that this half is congruent to this half. So it's perpendicular bisector. Bisector means to cut in half. So there's our 2 equal halves, and there's our 90-degree angle that makes it perpendicular. So the perpendicular bisector theorem says that if a point is on the perpendicular bisector of the segment, so for example, we have point C here on this perpendicular bisector, then it is equidistant from the endpoints of the segment. So what that means is that this point C is an equidistant from the endpoint A to this endpoint B. I'm going to use 2 tick marks to show that those are congruent because we already have 1 tick mark showing that AM is congruent to MB. So that's only true if M is the midpoint and C is on that bisector. So for example, let's see, find JM. So since this is perpendicular, and we have MK as a bisector, we know that it's a bisector because 5 is congruent to 5. Those are the same lengths, so we know that MK is a perpendicular bisector, which means that M is an equidistant from the 2 endpoints. So M is the same distance to L as it is to J. So we know these 2 segments are congruent. So if ML is 12, then we know that MJ is 12, or JM. So one more. Again, we have a perpendicular bisector QS here. How do I know that? Because these halves are marked congruent, so we know it's a bisector, and there's a 90-degree angle, so it is a perpendicular bisector, which means that the point Q on the bisector is an equidistant from the endpoint R to the endpoint P. So we know that this is congruent to this. So 5x equals 3x plus 8. Let's move all of our variable terms to one side of the equation. I'm going to move them to the left side. So we get 2x equals 8. Let's isolate our variable x, and we get x equals 4. But that's not what we were trying to find. We were trying to find the length of QR, and QR is 3 times x plus 8. So let's plug in 4 for x. That gives us 12 plus 8, which means that QR is 20.